This time on Mega Shippers. In Liverpool, northwest England, heavy lift specialist Alistair Smith brings in massive machines to take down and move 1,000 tonnes of raised dual carriageway.
It's one of the most complicated lifts that we've taken out. We're under a lot of pressure at the moment.
In Shoreham, on England's south coast,
This isn't for the faint-hearted.
operations boss Robin Merry is in a race against the tide to unload 2,000 tonnes of timber in 2 hours.
We've probably got about 20 minutes left. So we're right down to the wire now, it's really close.
And in Spain, programme manager Andre Borges' plans fall apart on the first stage of getting a multi-million-pound satellite designed to identify planets that could sustain life into orbit.
There is a mistake. The truck in which we have loaded the sea container should be this one. We have swapped the trucks.
Around the world,
We are going in. Let's go.
there's a hidden army of workers
Things can go wrong really, really fast.
who, in the face of danger and turbulent times, work in all weathers, day and night, to deliver no matter what.
Stop.
Step into the $6 trillion world of heavy logistics. Meet the people for who no load is too heavy,
Anything up in the air, it wants to come down.
no item too big,
It's a case of demolition, destruction, and make it happen.
and no route too difficult.
The more that I get off, the less stress that I have.
An industry dedicated to one common goal:
Keep it going, mate, keep it coming.
keeping the planet moving by land, air, and sea. Meet the Mega Shippers. Liverpool, northwest England. With a population of just under 500,000, this vibrant and busy city faces a problem. Whilst in the 60s, local boys the Beatles were hot, some of the architecture and town planning from the same decade was definitely not. Specialist engineers have declared the city centre's elevated flyover roads unsafe for traffic.
The bridge has been condemned. It's basically got a few faults with it. Some poor craftsmanship in the 60s when it was constructed. So now we're here planning on the demolition of the Churchill flyovers, both north and south.
Despite standing for just 60 years, the faults found within these concrete carbuncles are so severe they can't be repaired, and it will cost the council an estimated £60 million to replace them. With plans in place for a new open-plan traffic scheme, the council are calling time on these historic high roads. Demolition specialist and project manager Daniel McKinley is part of the team responsible for taking them down.
So the bridge isn't being demolished in its normal conventional methods using mechanical excavators due to the location of the site.
Besides the cramped city centre working conditions, this 4-month-long, £6.75 million project presents other unique challenges for Daniel and his team.
With the museum being so close, there's many artefacts in there that are obviously priceless, hence why we're not using heavy mechanical demolition techniques to minimise the vibration and to minimise any damage caused to either the museum and the artefacts within it.
With priceless artefacts dating back thousands of years, explosives are out of the question. And clearing demolition rubble would take days and mean closing multiple city centre roads for weeks. This sensitive job demands innovative engineering. The 2 sections of road that need dismantling are supported by concrete pillars up to 10 metres high, and both are over 240 metres long. The solution? Supporting, then cutting these 6,000-tonne plus spans in situ into 28-metre sections, lowering them to the ground, then cutting them into smaller sections to be transported off-site to be crushed.
Dan, here, have you got to put another one in here?
The city centre roads under the flyovers have only been closed for 48 hours, so project manager Alistair Smith from heavy lift company Sirens has brought in specialist equipment to deal with this time-critical challenge. Alistair's key to making the move go smoothly, a giant remote-controlled vehicle known as an SPMT.
So this is an SPMT, self-propelled modular trailer. The trailers themselves are built up in 24 axles. This configuration is good for over 1,000 tonnes. We're taking down bridge sections of up to 600 tonnes.
Besides load capacity, manoeuvrability is critical for the job, as the location and nearby important historic buildings means there's little room for error. SPMT's wheels can turn 130 degrees, so they can circle drive around the centre of the trailer or even propel sideways, executing crab moves, ideal in these confined conditions.
One of the reasons we're using SPMTs is there's precision. The precision of the SPMT, we can move in within millimetre tolerances, and that's what we need here.
As the winter evening draws in, Alistair gathers the night shift team for a final briefing.
We've built all the levels up under the SPMTs, where the SPMTs are going to go under the bridges, and we can put the trailers in, we can check the levels, tow, make sure we're OK. And that's us. So all the prep sites, you've got one trailer in this position here, one trailer there, all ready to go, check your fuel levels, make sure you're OK with that.
Finally, with all checks complete, it's time to get the job underway.
The SPMT is now moving into position. 1,200 tonne of capacity. We've got over 100 tonne of steel on the top of the trailer to make sure that when we pick up the load, it's not going to bend, deflect, and we can pick it up with the critical tolerances that we need to work to.
Accuracy is everything, and incredibly, this massive machine, moving at just 1 kilometre an hour, is operated remotely by this tiny joystick, a remote control unit.
Moving in position is critical. We need to make sure within tolerance of the exact positions as per the structure, so we're not going to overload a certain point. Just need to take the 2 seconds, hang on.
Safety must come first, and there's no way of rushing this job. But with the roads closed for just 36 more hours, Alistair is working to a deadline that can't be moved.
It's critical that we don't delay the programme. This is the massive problem that we have. We're in the city centre of Liverpool. It's a very, very busy thoroughfare, and we need to make sure that the people can go to work on Monday morning.
But with a margin for error of less than 40 millimetres, Alistair discovers the SPMT is in the wrong position.
Can't come in like that. It is tight, but you need to throw this end fully round and come in square, so you need to tell him he can't come in like that.
Madrid, Spain's most populous city and thriving epicenter of technological innovation for centuries. Today, it's at the forefront of cutting-edge aeronautical invention. At the Airbus production facility 20 kilometers from the city centre, there's a project underway that is out of this world. The European Space Agency have spent 5 years and millions of pounds creating a unique satellite, nicknamed Cheops, with a powerful telescope that can study planets outside our solar system in the hunt for those that could sustain life. And it's time to get it out of the factory and into space.
It's the last time that Cheops satellite will be in our facility, so it's kind of sad.
Cheops is being sent 800 kilometers by road to Toulouse Airport, then flown 7,000 kilometers to French Guiana, before it's finally launched into space inside a rocket. The most challenging and risky part of the whole £100 million project, the journey, begins today. But first, it has to be moved into a specially designed air freight container, with its own climate control, air pressure monitors, early warning system if levels change, and internal dampers to minimize vibrations during transportation. The satellite has been carefully wrapped in sterile sheets to prevent as much molecular and particle contamination, like dust, as possible.
This is the starting of the transfer.
Vanina Fikaja is Quality Control Manager.
We see here that the satellite is a little bit unbalanced, so right now what we're gonna do is balance it the right way in order to have a perfect transfer to the container, basically.
The 290 kilogram space telescope has a large ring that will attach it to the aircraft. It's the same one used to attach it to the container's mainframe to minimize any movement.
What we're doing now is, as the satellite is correctly screwed and fixed to the interface of the container, we remove the crane and the lifting device, and we're gonna pack it in order to send it to French Guiana.
As the final sterile cover is put on, they're ready to enclose the satellite in its container. An overhead crane moves into position. 4 straps with a 4,000 kilogram carry capacity are attached, and the whole roof section maneuvered by remote control. As it's lowered over the top of Cheops, centimetre by centimetre, any miscalculation could put this 5-year space mission back to square one, damaging not only the satellite, but also the specially built 300,000-pound container. Finally, it's down. The shackles are released, and it's moved outside to the loading bay. Cheops' only protection now is the hermetically sealed and sterile environment inside. Program manager André Borges has overseen the container's design and build from the start.
This is the air conditioning system. It's like the air conditioning system that you may have at home to keep the environment of your living room in right conditions of both temperature and humidity. Basically, this is the system.
Product assurance manager Jose Lozondo is checking the waterproof tarpaulin covers every inch.
Just to avoid any additional potential damage with rain and so on, because the weather forecast is saying that maybe it's some rain in the road. After maybe 5 years of working in chaos, I think that is the best moment in the schedule, in the project. So now we are ready to put our little baby in the space, so it's fine.
Outside, transport has arrived. 2 trucks, one for Cheops and another for its launch equipment. Before Cheops can be loaded, a container full of launch equipment goes on first.
We have a plan to the weight distributed in the truck. So for this reason, one of my colleagues is going to measure the dimension, exactly dimension of one container to put in the truck in the right position.
The launch equipment's crate is 3 meters tall, 2 meters wide, with a weight of 2 tons. Jose must make sure it's bolted onto the truck in the exact position calculated as safe for its mass. If they get it wrong, the truck will be destabilized, and millions of pounds and thousands of hours of work will be at risk.
It's okay. We put the big container here and then the container of the tilting trolley.
Cheops and its launch equipment needs to be on the road within 2 hours. But it seems not all the launch equipment is ready, and plans are afoot to move on to loading the other truck and Cheops instead.
To remove this truck in order to put the spacecraft, because the next activity in this truck is to put a lifting device, and the lifting device is not ready. Yes, for that we need to leave this truck to install the other in order to share the spacecraft.
The second 16-meter truck gets into position, just as program manager André Borges realizes a transportation mix-up could mean loading Cheops is impossible.
There is a mistake because the truck in which we have loaded the sea container should be this one. We have swapped the trucks.
Shoreham Port, 11 kilometres to the west of Brighton, is one of the largest cargo handling ports on England's south coast. Established by the Norman conquerors towards the end of the 11th century, its proximity to France made it a logical place for travel and trade. The 90-metre-long S3E02 freighter has docked overnight with 2,000 tonnes of cargo on board and a very tight schedule. Head of Operations Robin Merry is the man in charge of offloading high-grade timber destined for luxury exterior decking.
This ship sailed from Sweden. It's been sailing for 2 days. She's carrying 576 packs of timber. It's the high-end, high-grade of timber. It's the good stuff. So this stuff has to give me a little bit more protection.
With only 2 tidal windows a day, where a ship this size can arrive or leave port, Robin and his team need to get the timber off the 4,500-ton carrier ship in time for it to catch the next high tide. And today, for once, time is on Robin's side.
We're looking probably 8 to 10 hours to discharge the ship, but this has been one of our lucky days. The boat's in between tides, so we've basically got more or less a full day on it. Right, we're heading up the ladder now. This isn't for the faint-hearted.
Robin must constantly monitor progress on the ship as well as off.
Hello, guys.
The wood is being lifted using a Senebogen 80-ton crane, lifting at a rate of 2 packs and 7 tons every minute. But the safety of the dock team is paramount.
Inside the ship, we have a banksman who's on the near side of the ship. He's working in conjunction with the crane. He's our safety man in the hold. He's like controlling the whole operation. He's using basically hand signals.
He's already pointed to me what next one he wants me to take, so I'm going to go in, have a little look. He's pointing his hand up.
As you can see, they're just hooking on now. Yeah, look, he's taking it up now. His signals send it up in the air. The crane driver's moving with him now, and out comes the timber.
9 metres above ground, crane operator Jake Hollins is a man of many talents.
I was in performing arts and musical theatre college before this, and yeah, I've done a bit of Shakespeare. But soft, what light through yonder window breaks? It is the east and Juliet is the sun. I can remember loads more, but that's all you're getting. It's hard to act and drive the crane at the same time.
To be or not to be on time is the question. But with 6 hours left, Robin's not worried.
We've got 6 forklifts on it today, and they'll be doing about 100 packs each on this boat roundabout, and they'll be doing just like a big circle, picking up the packs from the ship, taking it over to the barcode station, where we process the timber and we give each pack an individual barcode.
But just as everything is running smoothly, Robin receives a call.
A slight change of plan. We've just had the shipping company come on to us. Yeah, hi there, Steve. I hear we come up with a new plan there. It looks like we're going to be going a bit quicker now, does it?
The owner has booked the ship for a new last-minute job. They want it out of the dock 12 hours earlier than planned. The tide is rising fast, to the ideal depth for the ship to raise anchor, leaving Robin and his team just 2 hours to complete the job.
Whereas we were working on the principle that we could do this right to midnight, basically, to the next tide, they're going to try and make the end of this tide, which is 2 o'clock. I'm just going to have a quick chat with the guys on the barcoding station to see how many packs we've done now, give us some idea where we are. Sorry, boys, just give us some idea how many packs we've done so far. 300. We've done 300, and we've got, what, 570. So I would say that it's going to be outside our 2-hour slot, unless we're very lucky.
D27.
Robin's team have picked up the pace, but there's no guarantee they'll hit their target on time. "1,500 kilometres away, at the Airbus facility in Madrid, critical launch equipment for Cheops, a satellite that will study planets that could support life, has been loaded onto the wrong truck. Program manager Andre Borges is the man who needs to get the satellite to Toulouse Airport to catch a flight.
They are talking to the driver to see how to fix it.
Andre and the loading team must now work out the best solution to keep on schedule. With no time to unload and load again, they've come up with a solution that will hopefully work. Remove the sidebars and modify this truck to take the satellite instead. Cheops will travel 800 kilometers to Toulouse Airport, then be flown 7,000 kilometers to French Guiana before it's sent into orbit in a rocket. But first, this truck's solid mainframe, designed to hold and protect smaller loads, has to be partially removed along with its cover as it's adapted at speed, ready to take its cargo. 4 slings and shackles are attached to Cheops so they can bring it slowly into position. For Jaime, the truck's high sidebars are a problem.
We are preparing the transport for the container, but there is not possible to put over the truck. We need to move at the same time the truck and the spacecraft in order to install the spacecraft here inside.
It'll also be a tighter fit.
No, it's not difficult maneuver, but there is 1 millimeter, so gap. It's only this is the problem.
Suspended a meter above ground, the satellite carrier is held steady. Inside, the multi-million-pound Cheops telescope is made of fragile parts, so the team must keep movement to an absolute minimum or risk the entire project before it even gets into space. Once loaded and bolted, its inbuilt dampeners will minimize vibration. It's swung round at 90 degrees, in line with the truck bed. With only 30 centimeters either side, the truck is then reversed underneath it. As it hovers 20 centimeters above the trailer floor, it's lined up ready to lower. It's close. But not a perfect fit. Rubber dampening pads are used to make the fit secure. As the 4 shackles are removed and bracing straps tightened, 2 generators are loaded to power the satellite carrier's air conditioning unit during transit. They're vital to prevent humidity and condensation on Cheops' telescope lens. With everything now on board, Cheops becomes the responsibility of Airbus escort Jose Clemos, who'll follow in a support vehicle on the 8-hour road trip ahead.
I check regularly 2-3 times by day, maybe 4, when it's too hot or it is too cold. I must look for the temperature on the container. No, always 22 degrees, not more.
He's being briefed and is now a man on a mission.
It's big responsibility because it's very, very, very expensive. But normally it's professional people, drivers, everything is always working. It's good. Normally it's good.
In the heart of Liverpool, heavy lift specialist Alistair Smith is battling against the clock to remove a concrete span from the city centre's 2 condemned flyovers.
This one here is the heaviest and the longest, so it's 588 tonne, 28 metres long and 9 metres in the air.
Part of a 4-month-long, £6.75 million project, both of these 50-year-old flyovers are being dismantled in 10 sections, each weekend over 4 months. But with just 24 hours before the roads need reopening for the Monday morning commuter traffic, Alistair is worried there may not be enough time.
So realistically, we've got 8 hours cutting the sections once we've got the trailers in to 10 hours. So 8 to 10 hours at best.
Taking the strain of the load are 2 SPMTs, self-propelled modular trailers. And with no margin for error, as even 1 centimetre could put the entire operation at risk of collapse, these massive machines need to be perfectly positioned.
The tolerance you'll have, mate, is about 40 mil. It's the yellow line there. Yeah.
2 SPMTs working in tandem will support the 584-tonne, 28-metre-long concrete span. It will then be cut into 2 14-metre-long sections, which will then be individually removed. But just getting these massive machines in place is a challenge in itself.
We're moving the SPMTs into position. The tolerances are critical at this point. We need to make sure that we're watching the underside of the bridge and the trays are the correct level. So when we come in, we have this 40 mil tolerance.
After some careful repositioning, the first SPMT is finally in place. And the second moves into position.
We can't do anything until both trailers are fully in. You can't make one cut until we've taken 50% on both trailers.
Once positioned, millimetre by millimetre, the SPMTs can elevate their specialist steel cradles to each take half the weight of the concrete section.
What we have to do now is make sure that we've got the exact position in. Remember, we have to hit the strong points on the bridge.
Locked in place, they will hold the 28-metre-long, 584-tonne section as it's cut free and removed from the flyover's main structure. Over the next 8 to 10 hours, specialist cutting teams will try and slice through the 50-year-old reinforced concrete, so this section of the flyover can be removed in the morning.
When we take it down a bridge like this, we use a diamond wire, which is like a big, thick cheese wire, which goes around the bridge and tightens itself around the bridge and starts to slowly cut through the concrete.
Working on a pulley system, the oil-lubricated, diamond-encrusted abrasive wire wraps around the structure rather than chiseling into it. There's much less dust and vibration, perfect for slicing through heavily reinforced concrete in awkward spaces. But as engineer Robert Frost explains, technique is everything.
So the cut lines are designed to be angled vertically and horizontally. So that means that as we come up and drive out, the gap gets bigger.
A diagonal cut at each end of the 40-metre span means in theory it's just like removing a slice of cake. But as the first section is about to be lifted, Rob spots a problem.
What's happened is one of the cut lines has kind of gone around a bit of an angle, so we haven't got the extra gap that we was expecting.
A jagged angle means the bridge section can't be removed cleanly. But fortunately, Robert's come up with a time-trusted solution: brute force.
So as you hear behind me now, we've got a jackhammer on it to take away the bit of concrete that's causing us issues. All hands on deck to get it finished. So we've still got to remove these two bridges, clear all this rubble, earthworks that we've done, clean it all out of the way, wash down the road, sweep it so it's clean for road vehicles come Monday morning. It's all pressure, isn't it?
Finally, with the cut line straightened out, the concrete span can be removed. And Alistair can try to get back on schedule.
It is a relief to see the SPMTs at one of the major bridge sections coming out. It's one of the most highest and complicated lifts that we've taken out, so it's good to see this is coming out now.
Transporting 574 tonnes of concrete 7 metres up in the air is a challenge. It must be kept level, or a shift in balance will cause it to topple over.
Powering along quite nicely now, not too fast. We're currently got 485 tonnes on the SPMT, so it's not full capacity, but it's getting there.
Although one SPMT is on the move, this is only half the job.
We're under a lot of pressure at the moment. We're currently about 6 o'clock on Sunday evening, so we've got just over 14 hours to get the road back open again, so it's a lot of pressure now to get the second unit out so commuters can carry on and travel through the tunnel tomorrow and into work.
In the hills of central Spain, Jose Clemos is overseeing a convoy of millions of pounds worth of cutting-edge satellite on the 800-kilometre journey to Toulouse Airport. From his support vehicle, he's keeping an eye on the trucks from behind. On one is the multi-million-pound satellite Cheops, and on the other, its vital launch equipment.
Now it's 13 degrees, so 13 degrees, before was 15, 16, it's no problem because it's not warm. The satellite is, with this temperature, stay in good condition.
Humidity could cause condensation on the lens of the Cheops telescope. It's enough for the planned European space mission to be aborted.
It's possible we find some storms in the north of Spain and south of France. It's possible. The weather is a little bit bad.
As well as keeping an eye on the temperature and the midnight delivery deadline, Jose's role is to ensure the load stays secure on the trucks.
Elle traîne par terre, ça il faudra s'arrêter juste un petit stand pour la mettre en place. When the strap is going, so we must stop to put it. The driver goes quickly. Very, very dangerous for the traffic. So we stop, quick stop, 2 minutes and we go again.
With all the bindings tightened, driver Christian is safe to carry on. But a gradual change in the weather has unnerved Jose.
Now we are going to make a break, half hour, and we are going to check the container. The temperature is okay. because now it's only 10 degrees, and normally he must stay in 21, 22. So we must take a look if the generator is working and is the good temperature in the satellite.
2 generators on the back of the truck power the satellite carrier's vital air conditioning system.
I'm taking a look, the pressure is okay. Normally it's 3, 5, 6, this right. And also, very important is the temperature. That is 22 degrees, so 22 degrees is perfect.
Jose and the convoy forge onwards into the night, towards the French border. The plan was to stop en route whenever needed, so Jose could do his checks. But still 600 kilometers from their destination, he's having to change strategy.
Well, the weather is very, very bad. It's raining very hard.
It's now 10 p.m. It's been raining non-stop for the last 3 hours, and he's been checking every 60 minutes.
Drive 5 kilometers more, and we stop in one station to take a look for the container and everything. This is going a little bit down. Just a little bit. It's just 5, it's okay. 22.
The 2 generators also now need to be checked. In these conditions, they're working overtime.
In no diesel, we have more than a half, so it's okay. Everything is going very, very good.
The KOPS satellite has to be in Toulouse by midnight, ready for a new team to take over. They'll deliver it airside at Toulouse-Blagnac Airport, from where it will fly out to French Guiana the next morning. But the weather is out of Jose's control.
Now the weather is very, very, very bad. It's raining very, very hard. It's dark. The satellite is very, very important and expensive.
At midnight, against the odds, 8 hours and the full 800 kilometers later, he finally rolls into Toulouse bang on time. Shoreham Port, England. And Head of Operations Robin Merry is racing against time.
I'm not sure if it'll make it or not.
Together with his team of 10 men, they have 60 minutes to finish unloading 2,000 tons of timber. The ship's owner has scheduled in a last-minute job, and they need to catch the next high tide at 2 p.m. to hit the deadline.
The ship's just now firing up its engines. We can see the smoke just come out the top, and the engine's just started to spin up the water at the back. So we're still right on the borderline, but she's trying to get away, as you can see. She's preparing herself. We've just got to try and get the last bit off in time.
Robin is also concerned about unloading too quickly.
You've got to be careful when you're discharging a ship like this. You can't just pour a big lump out in the middle and a big lump here and a big lump there. It's got to be done in a nice, organised process. So if you were to take the cargo out of one side more than the other side, the ship would lean. If you took it out of this side more, it would lean, so you're going backwards and forwards. So the ship's got marks on the side of it. We need to keep them as level as we can as we go up the boat.
Also feeling the pressure, 9 metres above the dockside, is crane operator Jake Hollins.
You've got to keep your wits about you, like, at all times. A lot of things that could go wrong with it, you know, you could have a sling go on the pack, you could have a forklift going in when he's not supposed to. Eyes everywhere you've got to have, eyes everywhere.
While Jake unloads another 7 tons of timber, Robin receives news from the bridge.
Hello, mate.
The ship's harbour pilot has been monitoring the tide times and depth of water.
Right, the heat's on now. Things have gone a bit more in our favour. If the pilot should just come back to us, we've got another half an hour. So where at 2 o'clock we thought was war on the real impossible side, that extra half hour might make a big difference to us. Hello, guys. Just a quick idea of how many we've got left on the boat, please.
About 50 packs.
About 50 packs. So we've got about 25 minutes to go, 25 lifts. We're right on the clock. It might just get this. We might have it yet. We're not sure. Cheers, guys.
Dockside, Robin steps up the machinery.
Usually we'd probably have 6 forklifts working, but now we've gone up to 8. Because we've got a bit of a deadline we're trying to push, trying to keep one of our regular customers happy, we put an extra 2 trucks on it, we're going to try and push it through. We've probably got about 20 minutes left, so we're right down to the wire now, it's really close.
The ship's crew need all hands on deck to raise the anchor and hit their departure window.
10 to Jake, how's it going up there, mate? Good?
And an anxious Robin can only look on as the wood is still being unloaded.
Looks like 2 lads to go.
The captain gives the order to raise the ladder, doing everything they can to leave on time.
Okay, mate. Right, let's have a quick look where we are. Whoa, right, we're 25 past the hour now. We're virtually on the last of the lifts. Ship's engines are running, the pilot's on board, the ladder's up. We're right on the wire, but I think we're going to do it. I think we've made a great success of this. Whoa, I think we're there. I really do. It's very rare you see a ship this tight. It's probably one of the tightest ones I've ever had. Right on the edge it is, right on the edge of getting there.
The ship can't leave unless the cargo is fully offloaded. Robin's team keep going, desperate to hit the deadline. And it's the job of the ship's pilot to break the news to Robin that all the effort's been for nothing.
No good.
Still got about 10 packs by the looks of it to go.
Yeah,
14:30 was the latest. So
yeah, so
unfortunately.
That's fair gun. Yeah, you can't do any more than that, can you?
I'll be the captain 22:30 this evening.
The ship has missed the high tide and will now be staying in the dock for another 8 hours. With the last of the wood offloaded and the ladder still raised, the remaining team are winched off board.
Let's have a look. Whoa, 38 minutes past. We're 8 minutes beyond what we would have been to get this boat on a tide. Great driving of the old crane there. Spot on, mate.
You win some, you lose some, it doesn't matter. It is what it is.
For Robin, working dockside is all about the challenge, and this job has certainly been that.
The team actually made a fantastic effort, you know? That was maximum speed they were going, as safely as you can get. And that's fantastic work.
It's Sunday evening in Liverpool, and Alistair Smith is about to lift 584 tonnes of concrete.
Check on the drawing.
Yeah.
They still need to remove the second 28-metre-long concrete span from the condemned 1960s city centre flyover before the roads can be reopened for rush hour in the morning.
It's a big push to get the road open. The challenge is against us, definitely.
With the first 14-metre cut section of the bridge successfully removed, the second self-propelled modular trailer can slowly begin extraction.
So the S3E02s are now moving the second of the 2 bridges. This is the heaviest and the tallest bridge that we have. It's 588 tonnes, so it's one of the most critical moves that we've had to do in the whole project.
But finally, Alistair's team have done it. Over the last 36 hours, they've successfully removed over 1,000 tonnes of bridge and concrete.
So that's everything done now, which is good. We've completed all the work, which is great. The road will carry on open. Now we can go home and get some good sleep and come back on Monday morning nice and refreshed. It's been a few stressful days and a few stressful nights, but we've got there in the end.
For now, Alistair can relax. With the concrete spans safely removed to a holding site out of harm's way and the roads reopened, the next stage of the operation can begin in the morning. Taking over on the next stage of the operation, lift supervisor Lawrence Knight.
That bridge deck will come down probably about 7 o'clock tonight, if we're lucky. So it's going to be nice and dark. Never good lowering things in the dark, but it's winter time, so that's what you can do.
One of the daunting tasks Lawrence faces is lifting last night's 287-tonne, 14-metre-long concrete bridge span off the SPMT and onto the ground, so it can be broken up and easily removed from site.
All right, well, it looks as though we're good. We'll set the computer up, and assuming it all works, then we'll start lowering.
But operating an SPMT and overseeing the site isn't a one-man job.
I think it's just me I think everyone else has gone for lunch. I'm quite happy that this has been quite an easy, well, I'm saying easy, guaranteed something's going to go wrong today. We've got a complete electric circuit, so I'll start the engines up and just see what's happening. Where are we? Come on, honey. There we go. That's a start. The transport's coming in, the guys are driving it in, but before it comes in, I've actually got to mark where it's got to go.
Lawrence needs to precisely position the 17-metre long, 5-metre wide SPMT under the lifting cradle.
Take it over that way a bit. The line was good, it's just in the wrong place.
Made up of 4 12.5-metre high individual towers, this lifting cradle has been configured as a pair of 2 towers.
It's looking good. This is okay. This one's nice. What's the other one look like?
Taking the strain will be 2 hemp slings, each capable of holding 200 tons.
Yeah, shut yourself down, yeah.
Connected to the lifting beam, they will support and raise the concrete section, allowing the SPMT to be removed before the concrete bridge section is lowered to the ground.
Right, well, everything's connected now. The slings are on. It's lifting off. It's off. The deck section is now floating, about 50 mil, let's say, off of the actual trailer. We're holding it for 10 minutes just to make sure it's all settled and everything's actually happy before we remove the trailer. Just make sure nothing weird happens. And hopefully it doesn't get any more exciting than this. Boring is good, and this is now very boring, which is what we want. Exciting means run away, basically.
With Lawrence confident the slings can hold the 294-ton concrete section, the SPMT lowers its suspension and is carefully manoeuvred out. With the SPMT safely out of the way, the final stage is to check the computer data and lower the cut bridge span to the ground.
It's starting to come down now, so half an hour, 40 minutes, it should be on the dirt, which is what we want, and then we can all go off. Tomorrow morning we'll pick it up, put the actual temporary works underneath, lower it down, release the slings, and then start stripping.
Alistair, Daniel, Robert and Lawrence have cut and removed over 10,000 tons of concrete, but there's still work to do. The spans they've cut need breaking up and removing from site, where it will be used as filler and base for a new road that's being built.
Basically it's done. This is the last operation for the SAR lift and the last operation for the SPMTs. So as of tomorrow, SPMTs to go, SAR lift to go, ready for the next job, wherever that's going to be.
1,500 kilometres away in France, the CAOP satellite is about to go airside at Toulouse-Blagnac Airport. One of the biggest planes in the world, the Antonov 124-100 is on standby and ready for loading. Flight manager is Alexei Zyatinov.
This is a cargo cabin. We have in aircraft 2 internal cranes with the capacity 30 tons, which we are using for loading aircraft from the back side, from the rear ramps. If it's stuck somewhere, we bust it.
It's now 2 a.m. and Alexei's crew have been preparing the plane for the last 4 hours. Jose's plan has gone perfectly and the truck arrives bang on schedule for loading. The Antonov 124-100 has a maximum takeoff weight of 405 tons. Powered by 4 jet engines, maximum cruising speed is 900 kilometers per hour. It's 69 meters long, 21 meters high, with a wingspan of 73 meters. But its most impressive feature is the 7-meter tail end ramp. Robin McTaggart, project coordinator, will oversee loading into the rear of the plane.
So we're gonna take the truck back up until we get to the plane, and then we will use the crane inside the plane to lift it and to load it into the plane.
Robin has a 2-hour window to complete the job.
We need to be done with the loading at 4 a.m. and in order to be sure we can take off at 6:30.
The launch equipment is being taken on board first. The 2-ton crate is hooked up to the Antonov's overhead crane and lifted into the hold. But the pressure of getting the final and most fragile part on board, the Cheops satellite, is starting to show. While the satellite is moved to the tail of the plane by forklift, engineer Roberto Palacios ensures the 2 generators powering the satellite carrier's air conditioning system don't stop mid-flight.
We are filling the generator for the last time before the flight. We are not going to really fill it up to the end, but just enough in order to be sure that if we have to make that technical stop, there is enough.
The team now have just 45 minutes to load the most important piece of cargo. The onboard bridge crane, capable of lifting up to 30 tons, is moved into position. And 4 hooking points, originally used to load helicopters and military tanks on board, are attached to the carrier with 4 high-tensile steel cables, each one capable of carrying up to 4 tons.
Almost done, looks good. First time we load that way, so pretty interesting too. But really happy that it's almost done, really. Pretty impressive, actually.
Impressive, but by now, at 3:25 a.m., it's freezing cold.
Yes, but that's always the thing with the Antonov. You have to prepare yourself and have some nice big coat and big socks and and just be patient. That's the key.
The crane is controlled by 2 operators on the loading platform. It's raised centimetre by centimetre and kept absolutely level. On the ground, some of the team responsible for building Cheops watch anxiously, as the product of 5 years' work is suspended 15 metres above the tarmac. As long as there's no lateral movement, as it's pulled into the cargo hold, the satellite has around a metre spare on either side. The final move is done by hand, with a team of 10 men, so the Antonov has an even spread of weight in the hold. For Roberto and the rest of the team, their part of this space mission is done.
Everything has worked perfect, so the loading in Madrid, the road transportation up to Toulouse, and now the loading into the aircraft, so everything has worked perfectly. And now we are ready to start the flight up to French Guiana and up to space.
At 6:30 a.m. and on schedule, the Antonov closes its doors back and front and is ready for takeoff. Cheops will have been in transit for a total of 12 hours and 50 minutes by the time it touches down 7,000 kilometers away in French Guiana. From there, it will be sent by rocket into outer space, where it will orbit 700 kilometers above Earth, studying planets for possible signs of life.